All right, everybody, hello and welcome back. Today what we're going to do is we are going to continue working on solving quadratic functions. So our first couple steps are going to remain the same. We are first going to set our quadratic equal to 0, which means we are looking for x-intercepts. Next, we're going to look for a GCF. Now what that means is if all of our coefficients have a number in common, a factor in common, we can divide it out and then divide the 0 side by that number. And that will allow us to continue our solving method, but with more simplified values. Now, if we can't find one, that is okay. Or if we miss one, that's fine. We'll just be dealing with slightly bigger numbers. Today, what we're going to do is we're going to focus on the quadratic formula. So the quadratic formula is a great method for solving quadratic functions when they're in standard form. And it is something that is always going to work when we have real solutions. Now, the problem is we got to remember what the formula is, and it's a little bit complicated for some of us, and the work that goes into it sometimes is quite extensive. So our quadratic formula is going to be x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And now these letters a, b, and c are coming from our quadratic when we are in standard form. So we are just pulling those coefficients and putting them in the correct place in our formula. And then we are going to simplify to find the x values that are our solutions. All right, so let's take a look at our first example. So we have x squared minus 3x minus 4 is equal to 0. It is already set equal to 0 for us, so there's the first step. Our second step involves looking at these coefficients to see if they have a greatest common factor, which they do not other than 1, so therefore that is done too. And we can just jump right into our quadratic formula. So remember, quadratic formula is always going to work when our quadratic is in standard form. What we are going to need to do is pick out our a, our b, and our c values. So a is 1, b is negative 3, c is negative 4. So I'm going to write out my formula. X equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. I'm just going to start plugging in my values here. X equals the opposite of negative 3. Well, the opposite of negative 3 is going to be positive 3 plus or minus the square root of negative 3 squared minus 4 times a times c all over 2 times a. All right, so we've got our formula. We just need to go ahead and simplify. So let me give myself a little bit more room here. X equals 3 plus or minus the square root of. Now, this value inside our radical here is called the discriminant. It is very important, and it tells us what type of solutions we are going to have when we are done solving. Now, we're not quite going to worry too much about the discriminant now. Instead, what we're going to do is we're just going to simplify that. And now you can do this in a calculator, or you could do it in your head. We have negative 3 squared minus 4 times 1 times negative 4 is going to give us 25. Now, x equals 3 plus or minus, well, the square root of 25 is 5 over 2. So our solutions are going to be 3 plus 5 over 2, or 3 plus 5 is 8, over 2 is 4. And then x equals 3 minus 5 over 2. Well, 3 minus 5 is negative 2. Negative 2 over 2 is negative 2. So our solutions are x equals negative 2 and 4, which we could get by graphing and double checking our work, or plugging into our original function and making sure it equals 0. Now, these are really nice solutions. Negative 2 and 4, they're whole numbers. And what that tells us is we actually could have factored this quadratic. In my opinion, if you're comfortable with it, factoring is easier than the quadratic formula, But the problem is factoring doesn't always work, so it's not always as reliable as our quadratic formula. This one's a little bit more complicated. We have 2x squared plus 2x minus 5 is equal to 0. My a is 2, b is 2, and c is negative 5. X equals the opposite of b plus or minus the square root of b squared minus 4 times a times c divided by 2 times a. So one thing I want to point out that I do every time is I make sure that whenever I am plugging in values into the radical specifically, but really all over my equation, I am plugging them in parentheses. Some of us might forget to plug in a value squared in parentheses, and although it doesn't matter here, it would matter if that value was negative. So whether we have the parentheses or not does matter, especially if that number is positive versus negative. So I can go ahead and simplify. So we get x equals negative 2 plus or minus the square root of, well, my discriminant is going to be 4 minus 4 times 2 times negative 5. That is going to be 4 plus 40, or 44 over 4. So unlike the last problem, our value, our discriminant, is not a perfect square. So I need to move over to the side here and simplify the square root of 44. Now to do that, we need to find the biggest perfect square that multiplies into it, which is 4. So the square root of 44 is equivalent to the square root of 4 times the square root of 11. The reason I wanted to do that is because now I get x equals negative 2 plus or minus. Well, the square root of 4 is 2, and I can't simplify the square root of 11, so that is going to remain the same. We are almost done here, but what we might notice is both of our values here, negative 2 and 2, can be simplified when they are divided by 4. I can find a common factor that goes into 2 and 4, which is 2, and divide out by 2. So if I divide this by 2, it will become negative 1. If I divide this by 2, it will become a 1 times the square root of 11, and 4 divided by 2 is 2. So my answer is x equals negative 1 plus or minus the square root of 11 over 2. Sometimes people like this to be written slightly differently. Kind of depends on your teacher's preference, but these two things are going to be equivalent. So our two answers are x equals negative 1 plus the square root of 11 over 2, and x equals negative 1 minus the square root of 11 over 2. Although those solutions look very messy, they are just irrational numbers, which means decimals that kind of go on and on forever. They're just regular numbers. They're just not pretty numbers. So here is our solution. Next, we have x squared equals 18 minus 2n. So this one's a little bit different because it is not set equal to 0. So what I'm going to do is I'm going to add my 2n over. So we get x squared plus 2n equals 18. And then I'm going to subtract 18 from both sides to get, sorry, I should have only x's in this. So let's replace these. There we go. So we end up with x squared plus 2x minus 18 is equal to 0. And now we can use our quadratic formula. X equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. X equals negative 2 plus or minus the square root of, this discriminant is going to be a little bit larger, but we end up with 4 plus, I think that's 72. Yep. So our discriminant is 76 all over 2. All right, so similarly, we are going to have to simplify the square root of 76. Again, The largest perfect square that multiplies into 76, which is just a coincidence because it's the same as our last one, is 4. So the square root of 76 can be simplified to the square root of 4 times the square root of 9. We get x equals -2 plus or minus the square root of 4, which is 2, times the square root of 19 all over 2. So same idea, we want to simplify as much as possible. These values can all be simplified by dividing by 2. So when we do that, we get -1, 1, and 1, which means we no longer need the fraction, right? If we're dividing something by 1, then we're not really dividing by anything. So our answer is x equals -1 plus or minus the square root of 19. So those are our two solutions, -1 plus the square root of 19 and -1 minus the square root of 19. Again, irrational solutions, not nice numbers, but decimals and numbers nonetheless. All right, so we've kind of got three main situations so far. We have a solution that is a nice rational number. We have a not so nice irrational number where we end up having fractions in our answers. And then we have, again, a not so nice irrational number, but this time we don't have fractions. The key here is making sure we are simplifying correctly. Now, we do have one more situation, and it's a problem like this. X squared equals 4x minus 11. If I move everything to one side, we get x squared minus 4x equals -11. And then x squared minus 4x plus 11 equals 0. Let's use that quadratic formula. X equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Now when we do this, we get 4 plus or minus the square root of, we end up with 16 minus 44, and we get a -28 over 2. The problem here is, to find our solution, we are going to have to take the square root of a negative, which so far we have been unable to do. Although we are going to get to it eventually, right now that tells us that we have no real solutions to this quadratic, and we are done. Okay? So 4 different situations here. The process is essentially always the same. We are going to plug into our formula once we are in standard form, and then we are going to simplify. It requires a lot of algebra work. However, none of it should be overly complicated. It just takes some practice. One more time, we do like the quadratic formula because it will always work when there are real solutions. It's just messy. It takes a lot of time. It takes a lot of work. And quite frankly, there is plenty of opportunities to make mistakes. But it is good because it always works. Factoring doesn't always work. Graphing doesn't always work to give us exact solutions. So that's one of the biggest benefits of the quadratic formula. All right, as always, thank you for listening. And if you have any questions or concerns, please feel free to reach out. Thanks.